Today, we use this circuit to further understand Kirchhoff's laws. I'll advise you pause this video and give this circuit a trial. Try and analyze the circuit, pick your current, and try and see if you can pick the loops. That said, let's get into class. Here is the circuit. The first thing I want us to do is I want us to redraw the circuit and along line pick the loops and along line pick the current paths. After picking the current paths, we'll select loops, then we'll be able to solve this circuit. Now I have simply redrawn the circuit. Now if you observe, you see that there's a node around here. I've splitted that node in here. Now look at this carefully. If current I1 emerges from here, current I1 will flow to this node. And at this node, I can have my current I2 flowing in here. So that if I2 flows here, on this loop, on this node, I will have my I1 minus I2. This is I1 minus I2. Then along this line, we've been told that what we have here is 6 amps. Now, if I have 6 amps flowing out here, I have I1 by I2 flowing into this node. Obviously, on this line of the circuit, what I have is I1 minus I2 minus 6. Now, at this node here, take note of this node. At this node, I have I2 flowing here. We also have 6 amps flowing in here. So what we'll have on this line will be I2 plus 6. Now, if you look at this point here, at this node here, I have I1 minus I2 minus I6 flowing to this node. Now, I want to take a part here. I want to have I3 flowing out here, so that what I'll have going to the 3 ohm resistor will be I1 minus I2 minus 6 minus I3. So that at this node, I have I2 plus 6 flowing towards this node. So that on this line here, what I have will be I2 plus I3 plus 6. Now, both of this current flows towards this node. Now look at it here this way. Remember we have I1 here. I hope that is where we started from. Now at this node here, we will have this current flowing down here. I want to just analyze it here. I'll have it as I2 plus I3 plus 6 has flown down this way. Then I have I2 now be plus I1 minus I2 minus 6 minus I3. I want you to observe something, so that at this node here, what I now have here is I2 gives away with minus I2, my 6 gives away with minus 6, and my I3 gives away with minus I3. So I'm left with what? I1 in here. So that tells me that I'm very correct with my current selection. What I have here is I1. Now, when selecting current, we've selected the current and we've tried to manage our directions. Even if our directions are wrong, we'll have the current value in negative 4. The moment I get my answers in negative, I know that all I need to do is change direction. I've emphasized this when I explained Kirchhoff's current law. So in case you missed that lesson, please do not hesitate to look up into the description where you'll find a link to that lesson. Now, and I still need to redraw this diagram. Now, if you look at this, I've simply redrawn the circuit. Let's label it. Let's call this place A. Node B, node C, node D, and let's call this node E. Both this point and this point are virtually. And let's call this node, I'll call this point G. And we divide this into three loops because we have three unknowns. Now the first loop, let's look at the first loop. Loop E, A, D, E. I'm starting from E down to A to D and back to E. Starting from E, I'll be talking of minus 2 I2, then up to A, there is no resistor after 2, then I'll come to 10, there's a 10 ohm resistor. Now if you look at this, when I took my minus 2, I was going alongside the same direction with the current, but in I3, I'm going against the current, it becomes plus 10 I3. Now again, I'm going against the direction of the current again, it becomes plus 1 into I1 minus I2 minus 6 equals 0. So let's expand. Opening the brackets, I'll be left with I1 is 1, then minus 2I2 minus 1I2, that's minus 3I2, and plus 10I3 is equals to 6. I have minus 6 here, obviously it comes to the other side, becomes plus 6. And this is my equation 1. The second loop we'll look at is the loop A, B, C, D, and back to A. Now from A to B, we have a 2 ohm resistor. That's minus 2 into I2 plus I3 plus 6. Then from B to C, we have just a 10 volt source. That's minus 10. We're going against potential. And from C to D, we have a 3 ohm source. That's plus 3 into I1 minus I2 minus I3 minus 6. And from D to A, we have a 10 ohm source. That's that's minus. We're going along the current direction. That's minus 10. That's minus 10 I3 equals 0. Let's expand this bracket. That will be minus 2 I2 minus 2 I3 minus 12 minus 10 plus 3 I1 minus 3 I2 minus 3 I3 minus 18 minus 10 I3 equals 0. Now let's collect like terms. I have 3 I1, 3 I1, I have minus 2 I2 minus 3 I2. That will be minus 5 I2. I have minus 2 I2 minus 3 I3 minus 10 I3. That will be minus 15 I3. And obviously, I have minus 12 minus 10, that's minus 22, minus 18, that's minus 40. Goes to the other side, it becomes plus 40. Let's look at the last loop. The last loop we'll look at will be loop E, D, C, G, and back to E. That is E to D to C, G, and back to E. Now, between E and D, there's just the 1 ohm resistor. That's 1 into I1 minus I2 minus 6 plus minus, this minus 1, sorry, this minus 1, minus now 3 into I1 minus I2 minus I3 minus 6. Then the 4 ohm resistor on G, between G and E, That will be minus 4i1 and plus 24 equals 0. Here's equation 2. Let me just identify my equations. Here's 2. Now, this splitting up becomes minus i1 plus i2 plus 6 minus 3i1 plus 3i2 plus 3i3 plus 18. And finally, I have minus 4i1 plus 24. Everything here equals 0. I'm trying to manage space, but let's create space at the top. Now, so that conclusively, I have here is minus i1 minus 3i1 minus 4i1. That's minus 8i1. For i2, I have i2. I think I just have one. For i2, this is 3i1, this is plus 3i2. Yes, this is plus 3i2. For i2, I have i2 plus 3i2, that's plus 4i2. For my i3, I have plus 3i3, that's plus 3i3. And I have 18. I have plus 6. I have plus 18. And plus 24. And plus 24. That makes plus 48. That makes plus 48 equals 0. So I can easily rewrite this equation as 8i1 minus 4i2 plus 3i3 equals 48. Sorry, this is minus 3i3. This is minus 3i3. Let me open a fresh page and collect my equations. Now we finish with the diagram. So I can let go of the diagram and concentrate on the equations. Comfortably, we've rewritten our equation. Now we can solve our equations and solve for each of the currents. But for this, I would like to use Gaussian elimination method. In case you missed our lesson where we explain Gaussian elimination method, please don't hesitate to check the description below. I find it very convenient and easier to use Gaussian elimination method for when I have 3 unknowns. Now here is, I can change this to my matrix form. Using Gaussian elimination method, the first thing is we want to make this item here 0, that is the item on the first column and on the second row. We want to make this first 3, we want to make it 0. To make this to 0, I'll simply multiply the entire first row by 3 and subtract from the second row. So it becomes, here's 1 minus 3, 10, here is 6. So this will become 0. The next item will be 3 times 3, that's 9. I have minus 5 plus 9, that will be 4. The next item will be 10 times 3, that's 30. Then I'll have minus 15 minus 30, that's minus 45. And the next item will be 18 times 6 times 3, that's 18. Then I'll have 40 minus 18, that will be 22. The next item here, I want to make 0 with the last row and the first item on the last row. That's my 8. To make this 8, I'll multiply the first row again by 8 and subtract from that last row. That will be 8 minus 8, that's 0. 8 times 3, that's 24, minus 4 plus 24, that will be 20. Then I'll have 10 times 8, that's 80, and minus 3 minus 80, that's minus 83. Then the last item here will be 48. 6 times 8, that's 48. 48 minus 48, then I'll have 0. Now, still on Gaussian elimination method, I want to make my last item here, this 20, I want to make it 0. To make this 0, I'll use the second rule. Now, to use the second rule, I can multiply 4 by 5 and subtract from 20, and that will make 20 0. So I'll do that every item on that rule. That is this rule times 5. Look at it this way. This is 1 minus 3, 10, 6. Here is 0, 4 minus 45. Here is 22. This will be 0. 4 times 5, that's 20 minus 20. Obviously, this is 0. Then I have minus 45. Minus 45 times 5. Minus 45 times 5. That's 2. Oh, no. Minus 45 times 5. That's 225. That's 225. Then I'll have 225. Then I'll be doing minus 83. That will be 225 minus 83. Minus 83. 142. 142. So I'll have 142. I have 22 times 5. 22 times 5 is 110. 110. 0 minus 110. That's minus 110. Obviously, this column here highlights my I1. Here is my I2. And here also is my I3 and my results. Now, considering the last rule from Gaussian elimination method, I know that 142 I3 will be the same thing as minus 110. I3 will be the same thing as minus 110 over 142. That's 110 divided by 142. 142. That's equal to 0.77 to be negative. I3 is equal to minus 0.77. That shows my direction of current was wrong. I need to reverse that direction. Now, to solve for I2, I know that 4 I2 minus 45 I3 will be equals to 22. So that's 4 I2 now minus 45 into minus 0.77 equals to 22. 4 I2 obviously will be the same thing as 22 plus 45 times 0. That's times, I can easily multiply this by 45. Still have it on my dashboard. That's 34.85, 34.86. That will be 22 minus 34.86. Now, so that's 22 minus 34, that is 4 I2 equals 22 minus 34.866. 22 minus 34.86, which is equals to 22 minus 34.86 86. -22 minus 34.86. 12 points. That's equals to minus 12.86. So that I2 obviously will be equals to minus 12.86 over 4. I2 is the same thing as minus 3.215. Now let's take the last. Now let's take the last row. That's the first row to pick our I1. Now that will come from 1 minus 3 plus 10. That will come from I1 minus 3 I2. Yes, I1 plus 10. If you've been following me, I3 is equals to 6. So that's I1 now minus 3. That's minus 3.215 amps plus 10 into minus 0.77 is equals to 6. So that I1 now minus 3 times minus 3.215, that's 3.215 times 3, that's equals to plus 9.645 minus 7.7 is equals to 6. So that I1 obviously will be equals to 9.645 minus 7.7, that's equals to 1.945. That will be equals to 6 minus 1.945. So that's this is 6 minus 1.945, 4.55. That's 4.055, which is approximately 4.1 amps. 4.1 amps. So with this, we've seen that though I picked wrong directions, we just need to change the directions. Our I1 is the same thing as 4.1 amps. Our I2 is the same thing as 3.215 amps. And our I3 is the same thing as 0.77 amps. I hope with this you further understand how to solve questions relating to Kirchhoff's law. I wish to see you in our next class. Thank you for staying with us and see you in our next lesson.